And it was a unique thing back then to be able to spot a satellite moving across the sky. Now you see, hundreds in 10 seconds. And back then it was if you saw a satellite, oh wow, I saw a satellite. It was unique. And now in Maui, actually, I've had the opportunity to see such a dark sky again, and it's taking me back immediately. I got to do the volcano tour, the sunrise tour, and pitch black skies, beautiful stars, and I got to see some satellites again, and it took me right back home.
We didn't have smartphones. We had very basic cell phones. And I remember we lived around Nellis Air Force Base in Las Vegas, Nevada, and we took our first trip using Google Maps, and it was, revolutionary. It was impressive. That was probably the biggest technological leap that I saw in that day.
Being able to track objects on orbit and identify what a breakup looks like when objects break up in space or collide in space or come close to each other, being able to do predictive analysis and make sure that we have a safe, sustainable environment was really groundbreaking. And it still is today. We're still figuring out new techniques.
Please welcome the commander of Maui's home team, the 15th Space Surveillance Squadron, Lieutenant Colonel Wagenbach, to introduce our next speaker.
All right, welcome back. I hope everybody had a great lunch. And as we get into this session, we're going to introduce a really interesting talk for our featured presentation. I'll introduce our two speakers, and then we'll have a little time for Q&A. Lieutenant Colonel Jason Altenhofen is the Director of Operations for the Space Safari program. He leads a growing 126-member launch, space, ground segment team that is revolutionizing the way that the Space Force delivers capabilities to support high priority and urgent combatant commander needs. Space Safari rapidly acquires and integrates low-cost and mature off-the-shelf technology to execute missions from cradle to grave. Lieutenant Colonel Altenhofen graduated with a degree in electrical engineering from Kansas State University. Wow, you're the only one. Only one. That's all right. We'll keep going. We'll see. Additionally, he earned his master's degree in systems engineering as a distinguished graduate from the Air Force Institute of Technology, which I assume there's a few more of those here. And then his co-briefer is Mr. Greg Less. Greg Less is the Victus Knox Launch Integration Lead and Deputy Program Manager. Mr. Less is also the Millennium Launch Systems Integration Peer Team Lead. He provides leadership to the launch site integration team and launch integration support to the company's various flight programs. Less's program experience includes multiple national asset systems for the Department of Defense and NASA, along with systems engineering leadership for commercial endeavors. He earned his bachelor's degree in aeronautical and astronautical engineering from the University of Illinois, Champaign-Urbana. There we go. There we go. And an MBA and a master's in aerospace engineering from the University of Southern California. Wow. Okay. Well, please welcome our briefers to the stage, and thank you.
All right. Thanks, Colonel Wagenbach. We were actually stationed together when I was a lieutenant. He was kind of a junior captain out at Vandenberg's, and so it's awesome that you're able to introduce us for this topic. So Victus Knox, awesome mission, right? Honored to be a part of it. There's a couple things, kind of the military, bluff things I want you to walk away or take away from this mission is really designed to move with speed. And not just the launch piece, although that kind of gets focused, right? Because it's pretty cool. But also, really from mission concept, the acquisition, the build of the satellite, getting everything ready and tested, integrated, all the training and rehearsals that we had to do, to logistics of getting to the launch site, to the launch, and to on-orbit operations. So a lot, we'll get into this through this briefing, a lot was crammed into a very short period of time, and that's really what Victus Knox was about. The other thing is, the incredible partnerships. We're one office in Space Systems Command out at LA Air Force Base, but we had to partner across the Space Force to make this mission happen. And since we're at the AMOS conference and really focused on space domain awareness, we would not have been able to do this mission without the incredible support from Delta II, in particular the 18th, 19th Space Defense Squadrons and the 20th Space Surveillance Squadron, who actually supported us as we were conducting our mission on orbit. So with that, I don't have a clicker, but go to the next slide. All right. So a little bit about Space Safari. Colonel Wagenbach did a good job kind of opening it up, but we were set up 3 years ago by General Thompson out of, as mentioned, out of Space Systems Command. In our charter, our mission is to be able to rapidly integrate and deploy space-based end-to-end capabilities in response to those urgent operational needs and requirements. So we're not a program of record. We don't ever intend to be a program of record. We want to be able to complement the program of records that deliver large capabilities by fitting into those gaps and seams that an adversary or other factors may come up to where we need to quickly deploy something or operate something in a different way. So kind of like Victus Knox, we're very focused on speed in terms of acquisition, so taking high TRL capabilities, figuring out ways that we can integrate it, and deploying on short timelines. We're not looking for the 100% solution. Oftentimes it's the 60, 70% might be good enough if we can get it up there quickly. All right. I'll lean on you, Greg, to kind of. There you go. So TACRS. TACRS is a set of initiatives that really enable the U.S. To rapidly respond to the dynamic environment on tactically relevant timelines. And so what we're really getting after is having the capacity, the capabilities, and the culture across the Space Force to address those unknown unknowns. As mentioned, kind of the charter is Space Safari. It's not intended to take over any particular mission area, but we really want to be responsive to the needs and have the capabilities and the culture to deliver on that. That could involve a rapid launch, or it may not. There may be other ways. It may not even be Space Safari that's responsible for those. It's a much bigger concept than just our office. All right. So now Victus Knox. So we're here to talk about. I opened it up, move with speed. So we had 1 year to build. So Greg will get into it in a minute, but to do this, we were able to take a vehicle off a hot production line and modify it for the orbit we were going into and integrate a different payload. We had to acquire a launch vehicle, and in particular, Firefly Alpha was who we selected. At the time, they had never had a successful launch, but they had an incredible way of getting after this mission. And so we put, not a lot of options out there, in the commercial industry, and we really worked with them throughout that year, and they did an incredible job of delivering, as you'll see in a minute. And then in addition, we had the ground systems that we had to get ready. And then the next, successive phases are really different ways that we were trying to escalate our readiness to be able to respond really as quickly as possible once we got that final order and those orbital parameters. And so that's what we'll walk through on the next set of slides, and I'll turn it over to Greg.
Okay, so the build phase is a year, right? How do you do that in such a short period of time? It helps if you're not starting with a clean slate. So we pulled the bus off of our production line, and then took advantage of the fact that we've got 80% vertical integration across all of our common core components. We've designed them to work across multiple mission orbits, so that gave us the flexibility and the freedom to then focus on taking a GEO bus, modifying it for a LEO mission, as well as the modifications that we needed to make in order to do the SDA mission. Additionally, we're flying the vehicle as the prime, so we need to pull together a ground system that will work with this spacecraft and with this mission. And so that gave us the opportunity to do that as well, using the in-house software that we already had. Basically, what we tried to do is leverage the capabilities that were in-house to the maximum extent possible, minimize the amount of reinventing the wheel that we'd have to do. This is sort of an understated slide. Hot standby is where we wait for the phone call. The real message is all the things we had to do in order to be prepared for that phone call. Starting with people. We knew we were going into 24-hour operations. We needed multiple shifts. We needed backups. You know, people get sick. In our case, people get married. People have kids. Life happens. So not only do you need multiple shifts that you wouldn't normally need, but you also need backups. We needed security. We were going into a payload processing facility that wasn't accredited, so we needed security. Those people need to be trained. All of our people needed to be badged and safety trained. And you start stacking that up and you realize that's a lot of people that you've got on a program that you normally wouldn't have, but it's to address the launch on demand. The other piece is the logistics. How are we going to get there? What equipment do we need? What equipment are going to be used when we're there? Who's providing all the equipment? How are we going to set up for fueling? All of those things that you would do on a normal mission, we now needed to get teed up and ready to go and rehearsed in order to be sure that we can meet the tight timelines. So we actually ran through a couple of timed rehearsals, trying to simulate everything that we could, validating our time ladder in some cases, refining it, covering the gaps and seams, and making sure that we were as confident as we could be when we did get the call. So we got the call. It was 0800, Friday, September 8th. First thing we need to do is gather the troops. We actually had a fairly comprehensive calling tree, not just internal to Millennium, but across the interfaces with our customer, as well as with the launch vehicle, up to the base, making sure they knew we were coming, making sure that everybody knew this was now go time. Pull the people together, load the spacecraft into the truck, the rest of our equipment, some final logistics, and then off we went through Southern California traffic, workday, rush hour, 405 and 101 if you guys are familiar. Eventually we get there. They actually wasn't, traffic gods weren't terrible to us. We get there, pull up to the facility, everybody gets through the gate good. Now we've got to unload, start wiping down and cleaning up for ingress into the clean room, ingress, set up our MGSE and EGSE, unpack the spacecraft, and finally we're ready to get to work. So we go through, it's a typical launch prep cycle. You test your vehicle, you charge your battery, move towards the hazardous ops, pressure demo, fueling, which, as those of you who have done this before are familiar with, that's really where the time sink is. Trying to get that as efficient as you possibly can. And you can't hurry those operations. They're the hazardous operations, safety's always first. So, we'll talk about it later. That's really where some of the time sink was, but we still were able to get it done, get it accomplished appropriately. And then finally, we've got to integrate onto the launch vehicle adapter. So that's an integrated operation with the launch vehicle team. So as we're going through this, we're bringing them in and teeing them up and getting them ready to go.
All right, so alert. So similar to the hot standby phase, we're just at an escalated readiness. So we're meeting daily. We're ensuring we're ready to go to receive that call and get those final orbital parameters to then turn on a dime and be ready to launch within 24 hours after we get that order. Next slide. Yep, next slide. All right, launch. It's pretty cool. It was intense 24 hours. So September 13th at about 4 p.m. In 2023, so a little over a year ago, we got the final orbital parameters and the go. And from then, our plans, we'd rehearsed it, we're ready to go. Everything just kicked into action. So, we'd have shifts, kind of like during the activation phase, we had to have shifts of teams, having already, been kind of adapted to those crew cycles. For those, many of you have worked operations before, and we had to ensure we had the right decision authorities, right? Things happen in launch, everything's condensed. So, we're under a strict timeline. We've got a launch window to meet, which was about 27 hours later. And so, we had to rely on and trust in the expertise of our team to make sure that we were able to really balance the risk of the mission with the risk of not meeting the timelines that we'd signed up to.
So we got up there, and we had initial contact on first pass, which was great because that first pass was actually a really short pass. You know, vehicle's working well, first contact. Now we've got a relatively short amount of time to go through all of our on-orbit test and checkout and get ready for mission ops. Fortunately, we relied very heavily on onboard automation. In this type of an orbit, it's not like GEO. You don't have constant contact. You can't take things at a measured step, look at it, come back later. And from a time perspective, even in LEO here, there wasn't time for that. So we relied heavily on our automated software. We had shifts running around the clock. We had command shifts, which were always at inconvenient times of the day. And then we had the engineering shifts at the other times, looking at the data, getting the next set of commands ready. So how do we do? Activation phase, the goal was 60 hours. It says 58, but it's not giving us enough credit. It was 57 hours and 43 minutes. You know, we launched on time. We have 48 hours to get ready for mission, and we did it in 37. So it was really satisfying. We hit our marks. We learned a lot of lessons, and there were a lot of lessons to learn. You know, from our perspective, you know, this was about pivoting to, you know, how do you do things on demand, which is a change in paradigm from how we typically work, right? Typically, you plan a schedule, you hit your schedule. You show up at the launch facility, you process, you fuel, you launch, you get out of the way for the next payload coming through. In this case, we were saying, hey, there's going to be a facility there. We're going to show up sometime, and they have to be ready to catch us when we get there. As far as people, you know, as a program manager, you know, you want to manage your people efficiently. You staff appropriately to your project. To accommodate all the shifts and backups here, I was between 3 and 5 deep on the depth chart. You needed that. It was a different approach to how we normally do business. We measure efficiently differently in this type of a program. We measure success differently in this type of a program. And even then, stuff happens. Fortunately, we baked in some slack into our schedule. We compressed it, but we tried to keep it realistic. We had an electrical storm. Now, if this was down at the Cape, you know, that's a daily occurrence. This was at Vandenberg in Central California in September. Quite literally, we had done more preparation for seismic constraints than we did for lightning. You know, earthquakes happen there. You know, as I mentioned, the logistics, really this, for us, as the contractor, there were technical challenges, but this was really about the logistics. How do you pivot and be able to respond on demand and meet this type of a mission? You know, and really the answer was people. You actually have to have the right people in the right seats who know the systems well enough that when things happen, and we did have a few incidents where, you know, we had to make changes to otherwise carefully crafted plans, we had the right people available, both on site and with reach back to the factory, that we can make the calls, adjust the plans. We didn't have to schedule an ERB 2 days later. So it really was a change in how we did business. You know, there are things we could have done better, things we wish we were able to do in parallel that we, instead of in serial. I mentioned earlier that we tried to simulate as many of the things as we could. Turns out some of the things that we couldn't rehearse are what came back and bit us. Fortunately, we had the schedule margin in there, and we had some people who accomplished some heroics, really, to allow us to stay on board, which is sort of the other lesson is for these types of missions, you know, planning is great, but, you know, sometimes it comes down to 1 or 2 people really being good and really doing the right thing, and those are the people you need on your team for these types of programs.
Yeah, and from a government perspective, yeah, I touched on it a little bit, but just the decision authority. We had a lot of trust from our leadership, and they were very gracious to push the decision authority down pretty low, and we really took advantage of that, and allowed us to be creative. And not only us in Space Safari, but our teammates across the board as we were trying to figure out the different solutions to the challenges that presented themselves. One particular example was there's a limited space in terms of payload processing facilities across the board. And as we were trying to figure out, okay, how is this process going to work to be able to effectively at any time call up and we need a place to go that's got a certain amount of cleanliness that we could process and encapsulate the vehicle. And it turns out there really wasn't that place at Vandenberg at the time. So Firefly took it upon themselves and working very closely with SLD-30 and the range safety folks to modify a building there at Slick 2 on Vandenberg and build their own payload processing facility. And they were able to do that in very, very short amount of time. It was very impressive, and we wouldn't have been able to pull off the mission without it. So that is now a new capability that exists today there at Slick 2, and we'll probably continue to take advantage of it, whether it's us or other missions going forward. And the other thing, that a little bit different, space, oftentimes we hear is overclassified. And one thing that really helped us is from the outset, we really tried to make sure that we drove down the classification to the appropriate level. And really what that meant is a lot of it's unclassified. I mean, obviously we're up here talking to you about it today. But that helped us communicate, helped us explain to many of our other agencies, FAA, FCC, other partners, what we were trying to do, what we're trying to accomplish, why it's important, and especially during execution to ensure we were able to move fast. It just really helped with the coordination. So yeah, so thank you. Thank you for coming to this presentation. We're not done. We're going to continue to press the ball forward with these types of missions and other types of missions that get after similar needs. And General Grant touched on one of those yesterday, but we're excited for the future and excited to continue to hopefully change the way we acquire and deliver systems at a more rapid pace.
Thank you.
All right, we just have a few extra minutes for questions. If you have any questions, please submit them via the conference app. I'll start you off with, can you kind of highlight some of the downstream things that you mentioned, the support from Space Delta 2. What did that look like, and kind of what were those touch points?
Yeah, so as we were getting into, especially in on-orbit operations, we were maneuvering, and from the outset, I mentioned we kind of stopped at the initialization. We had the 48-hour challenge, but even then, we had a mission that required a lot of maneuvering in LEO, and so that was mission planning daily, working with the SDA community to ensure that we're doing it in a safe manner. One of the red lines for this mission was we weren't going to do anything that was unsafe, whether that's something on the ground or in space. But we were willing to take risk from a mission standpoint if it balanced that appropriately. But that's one example. The other is we involved the 20th Space Surveillance Squadron really because we wanted to ensure that we had the operational perspective. And we want to be able to take this into a real, use it for real operations, this concept into real operations in the future. And so we wanted to make sure that we had the operational community involved from the start and throughout the mission to ensure we're on that glide slope to make it operational.
Great, thank you.
All right.